So I just want to thank you for the opportunity today to present some of the ways in which I've used R, and in particular a series of packages in R called the Tidyverse for manipulating and visualizing datasets. And I've said here large datasets. You can use this on any dataset, but it's particularly useful, I found, for complex and unwieldy datasets. So just a bit of an overview of what I'm going to talk about today. Firstly, I want to introduce you to what the Tidyverse is. And basically, the Tidyverse is just a series of packages in R that you can use to clean, manipulate, load, tidy data. But it uses this underlying theory of tidy data. And I'll introduce you very briefly to this concept of tidy data as well. And then I'll show some examples of how I've used the Tidyverse for data manipulation and plotting, but particularly using an example from a recent study that we conducted and published, looking at the performance of rural water supplies in Ethiopia during the El Nino drought in 2015 and 16. So the authors of the Tidyverse say this about the Tidyverse. The Tidyverse is an opinionated collection of R packages designed for data science. All packages share an underlying design philosophy, grammar, and data structure. And that grammar and data structure will be something that we talk about as we go through this presentation. So as I say, the Tidyverse is a series of packages used for manipulation, loading, tidying of data. I'm going to focus today on ggplot2 and dplyr. readr is used for reading data, stringr is used for manipulating strings and characters, tidyr is dedicated to tidying data, and there's several other packages within the Tidyverse. If you're interested to read more about the theory and the philosophy of the Tidyverse, then I'll refer you to these resources by Hadley Wickham. And then it's worth having a look at the Tidyverse website to get an overview and an idea of some of the things that Tidyverse can do. So as I say, the Tidyverse uses this concept of tidy data. So what is tidy data? Well, tidy datasets provide a standardized way for linking the structure of a dataset with its semantics. So in R, a dataset is typically a data frame, and I won't get into the theory of this too much, but a data frame is basically a collection of vectors. But in terms of the philosophy of what tidy data is, the key underlying theory and concepts of tidy data are that every value belongs to a variable and an observation. A variable contains all values that measure the same attribute and is generally the columns in the dataset, as you can see here. And an observation contains all values measured on the same unit. So our observations are generally the rows within the dataset. And then a value sits within the cell within that dataset. And any deviation from this isn't tidy data. And it's this underlying structure of data that the Tidyverse basically uses throughout all its packages to work with data. So what are some examples of messy data sets? Well, typically messy data sets might involve mixing variables and observations, or having more than one observation in a particular cell, or a combination of those. It might involve using column headers as values and not variable names. As I say, multiple variables stored in single columns, variables stored in both rows and columns, and in my bugbear, mixing different types of data. So i.e. mixing text and numbers, for example. So this is what we want to avoid, and we can't use the Tidyverse if we have data in this structure. But I'm sure all of you will have seen data that shows all of these different features of this messy data. But the Tidyverse provides a way for us to work with this data to convert it into that variable observation underlying concept of tidy data. So now that we know what the Tidyverse is and what tidy data is, I want to take an example from some of my work in Ethiopia, where we looked at the performance of rural water supplies during drought. So this just provides an overview of that work. So what we did was we looked at a series of different water source types: motorised boreholes, hand pump boreholes, protected wells, springs, open sources, and water trucking. And we looked at how each of those performed during the El Nino drought in Ethiopia in 2015 and 2016. And we looked at it based on the different altitude areas of Ethiopia. So in the lowland areas, typically you have more motorised boreholes, it's drier, people have to travel further to access water. As you move up into the highland areas, generally you have more protected wells, springs, and people generally have better access to water in the highland areas. So that was the framework in which we looked at the data. So we collected 5,196 data from 5,196 individual water points over 12 weeks of monitoring, and we ended up with greater than 28,000 individual site visits. So that represents our observation, and we collected data mainly on functionality, but also on user numbers, water quantity, and a few other variables. And just to give you an idea of what the data actually look like, so we have our variables along the top, we have our observations in the columns here, and this data set is what I'll refer to throughout the rest of the presentation, and just for reference, from now on, I'll call it ETH. But let's just take an example of some messy data. So most of this data has been cleaned, but any of you that are observant might have noticed that within the travel time column, my bugbear appears. So this represents messy data. In R, we can look at unique values within a column just by using this line of code. And we can see that in this travel time column, we have a mix of text and a mix of numbers. So we can't work with that in the Tidyverse, so we need to clean that up. And the Tidyverse provides us a way to do that. And as I go through this presentation, I am going to show code, but I don't want you to worry too much about the detail of this code. What I'm interested in demonstrating is the functionality of the code and how potentially it can be useful for sorting things like this out. So in this case, we use a combination of creating a new column and saying if we have a certain number, then assign a string to that number. So that replaces our numbers with text in this particular example of messy data. And then the text that we had before was quite long, so we've replaced that to be consistent with how we've replaced the numbers with these shorter strings. So that's an example of using dplyr to tidy up our data. So let's look again at the data set that we have. So from now on in the presentation, we're really going to focus on this part of the data, which is our functionality, information about functionality of each water source type. So just to zoom in on that, we have the different functionality categories, the different types of boreholes, the areas that they're in, and the week that the data was collected. And what I want to do is explain how we go from this to something that looks like this using dplyr and ggplot2. So the first step that we have to do is reformat the data so that we can produce these plots. So at present, we cannot go from this structure, which is what I just showed you, to this plot. So to do that, we have to use dplyr to manipulate the data. Again, I'm going to show some code here, but I don't want you to worry about the syntax or anything like that at the moment. What I'm trying to illustrate is the steps and the process of dplyr and how it can potentially speed up this type of operation to go from this to this. So we had our data set, and we want to create a new data set that we're looking at overall functionality. So how do we do that? Well, first of all, we group by the type and the functionality category. So that's what this allows us to do. Then we count based on this on this grouping. So we count the number of functional, partially functional, and non-functional motorized boreholes, hand pump boreholes, and open sources, and we get the total of each of those for each type. That's what this does, and we create a new variable doing that. Then we sum up the number of each type of hand pump boreholes, how many are there, and then we basically calculate a percentage of functional, partially functional, and non-functional boreholes for each washer source type. And this is what we end up with. So we have our type, our functionality category, our total number of non-functional, partially functional, and functional boreholes, the total number of each washer source type, and then our functionality rate. So this we can then turn into this plot, and on the next few slides I'm going to demonstrate how we do that. So before we do that, I just want to introduce ggplot2 to you. So ggplot2 is designed specifically for high impact data visualizations. It breaks up graphs into its semantic components, and it's based on this concept called the grammar of graphics. But basically it works by layering the different components of a plot. It takes 4 basic steps. First you assign the data, then you map the variable to an aesthetic. So you map your variables to colors, shape, sizes of shapes. We assign a graphical element. So we assign lines, points, for example. And then we basically just allow ggplot2 to do the rest. So what is a grammar of graphics? Well, a grammar of graphics provides a structure to combine graphical elements into figures that display data in a meaningful way. So we're going to use that grammar of graphics to create the plots that I just showed you. So this is the table that we created using dplyr. And what we want to do is we want to plot the type versus the functionality rate as a bar plot. So to do that, we call ggplot2. We then assign type and functionality rate, and we say we want to create a column plot. Basically, that's what this bit of code says. And this is what we get. So obviously at the moment, we just have grey bars that go to 100%, and we're not actually distinguishing between the different functionality categories. So we haven't assigned anything that distinguishes these functionality categories from this code. So to do that, we just add one line to this aesthetic. We say we want the color or the fill of the bars to be based on our functionality category. And then what ggplot does is that assigns a color to each of the different functionality categories: non-functional, partially functional, fully functional. And the rest of the code is the same. You can see it's a wee bit messy, and I'll show you how we can tidy some of that up in a minute. But before we move on, I just want to emphasize the importance of color. And I'll own up as well, I think this is something that I'm still very much learning about, and the importance of color. But ggplot2 has inbuilt functionality that allows you to think about color in a different way, and I think it's very important in visualizations to do that. But one package that I like to use within ggplot is the colorblind friendly package Viridis, and it just provides a series of different color palettes that allow people that are colorblind to easily distinguish between different variables, and it assigns these different colors to those variables. So I use Viridis within the plot I just created. So we go from the the red, green, and blue, and that is the default option in ggplot2, to the viridis colors, just using one additional line of text. So we're saying here that the data is discrete, so we only have 3 different variables. That's what the discrete refers to, and we assign the last option of the viridis color scheme. So viridis scheme are assigned there. So then we want to take this and we want to tidy it up, and we just specify the Y label, the X label. We assign a different theme. So this theme is just the number of built and themes within ggplot2. This gives us a basic X and Y axis. And then we also specify the legend title. And that's how we get the overall functionality plot within ggplot2. So it's only a few lines of code, and we get these really nice, clear visualizations. So then what we want to do next is we want to take this overall functionality and look at functionality of the water points in different weeks, and how the functionality of the water point changes throughout the drive. So how do we go from this plot to this plot? And that's what I'm going to talk about in the next few slides. So again, this is the table that we started off with. And again, we can't go from this to this, but we can use dplyr again to get to this point. So basically, it's the same as we did before, but this time we group by 2 additional variables. So in addition to type and functionality category, we also group by the week and the area. Again, we tally the groups that we create. We create a new total column and sum the number of different types within each category, and everything else is the same. And that gives us this. So again, we have the types, we have the week and the area for each functionality category, and we have a functionality rate within each area in each week for each type of water source. So we can then go from this to this using ggplot2. So the difference between this one is, in this plot we have these different facets. So we have a different facet for each water source type in each area of Ethiopia. And to do that, again, we basically use the same code as we previously used. We change the X variable in the aesthetic call, and we add 1 additional line. So the X variable we change to week. So we want this time the bar graph to show the functionality category versus the week, and then we want to break that up by area and type, and that's what this bit of code yields here. So again, just 1 or 2 lines of code yield these really nice, impactful graphics. And then we can easily include other features and plots. So in this example, which is the one I sent in the blurb that you might have seen, we've got rectangles that show the separate areas by their altitude. So we have the Kola up to 1,000 meters, we have the Wenedega up to 2,500 meters, and Dega beyond that. And to create these rectangles, all we do is we add another geometry by specifying geomrect, which is geometry of rectangle, and we just give it X and Y coordinates to assign each of these rectangles. And then we add the text, and again, we just give an X and Y coordinate to ggplot2, and we can put the text within these rectangles. So this one shows the total number of source types within each area and each altitude. So I think the really nice thing here is you have so much control over ggplot2 that you can really start to break things down into its different component parts and very clearly show that using visualizations. So the last thing that I did with this data, and I just want to show you, I think this demonstrates the real power of ggplot2. This graph is basically a summary of the overall performance of water source types within Ethiopia. And this was all done using ggplot2 and dplyr. But basically what I did was I created a data set that allowed me to look at the number of users, by the hand pump type over the different weeks, how the travel time is affected, and whether the users felt they had enough water. So what you can see, if we take hand pump boreholes, here you can see that with the shapes, is that the functionality of hand pump boreholes was very low to begin with, but it gradually increased during the drought due to a maintenance program that was going on, up to close to 100% by the end of the monitoring period. In the first part of the drought, people reported that they haven't had enough water from the hand pump boreholes, but in the second part of the drought, they didn't. And generally, travel times increased for people throughout the drought. So to begin with, the travel times were less than 30 minutes, but they went up to greater than that as we went on. And I did that for each of these categories. So this graph does take a wee bit of thinking about, but what it does is it nicely brings all the component parts of my analysis together in this one visualization. And just before I close, I just want to point out as well that one of the things that I find extremely useful more recently with ggplot2 is that you can use dplyr, ggplot2, along with some other packages in R, which I won't get into detail of, to plot spatial data. So this is just an example of some work that I've been doing recently in the northwest of India, looking at groundwater levels and the influence of canals on them. And again, what I've done here is I've used facets and color and shape to look at the different canal commands within our study area when they were built and how that's spatially distributed within our study area. So these same principles that I talked about for the bar charts that we've been using, that I showed you earlier, can be applied for spatial data as well. And that just adds another dimension to ggplot2, and I think for me really increases its power and its functionality for us as hydrogeologists. So just to summarize, the Tidyverse uses underlying data structure and grammar. These principles, hopefully I've demonstrated, make it easy to work with and visualize large data sets. dplyr provides the tools for manipulating large data sets. ggplot2 offers the user huge control over how that data is visualized. Both of these tools and all of the tools within the Tidyverse share an easy to understand syntax, and I think once you've understood the basics of R, it's extremely easy to then adopt the Tidyverse, and it's arguable as well that actually the Tidyverse is even easier to understand than base R syntax. So it's a really easy language to learn. And in combination, the packages within the Tidyverse offer a really powerful way to manipulate and visualize pretty much any data set. So thank you for your time. I hope you find that useful, and I'll be very pleased to take any questions.